The late afternoon sun cast long shadows across the barracks at Camp Shelby, Mississippi, as Friedrich Wilhelm von Mellenthin sat at a rough wooden table, his journal open before him. The date at the top of the page read November 23, 1944, written in the precise hand of a German general staff officer who had spent years documenting military operations across multiple continents. But the words he now struggled to write bore no resemblance to the operational reports and strategic assessments that had once flowed from his pen. Outside his window, the steady rumble of engines announced another convoy of American supply trucks making their way down the camp's main access road. Von Mellenthin set down his pencil and moved to the window, watching as vehicle after vehicle passed in what seemed an endless procession. Each truck rode on 6 tires that gleamed with the distinctive black sheen of brand-new rubber, the tread patterns sharp and unmarred by wear. The general counted 40 trucks in rapid succession before he stopped counting, his trained mind automatically calculating the resources represented by this single convoy. 240 tires, he thought, enough rubber to equip 3 full German infantry companies for an entire month of operations. And this was merely one convoy among dozens he had observed since his arrival at the camp 3 weeks earlier. What troubled von Mellenthin most profoundly was not simply the abundance of tires, though that alone defied every calculation he had made during his service as a senior intelligence officer and divisional commander. What gnawed at him was the casual, almost wasteful manner in which the Americans handled this precious resource. 2 days earlier, he had watched as maintenance crews changed the tires on a fleet of transport vehicles. The tires being removed showed minimal wear, perhaps 10,000 kilometers of use at most, yet they were being discarded and replaced with fresh rubber. In Germany, tires with that much remaining life would have been carefully preserved, patched repeatedly, and used until they literally disintegrated. The removed tires here were simply tossed into a growing pile behind the motor pool, destined for some recycling process that von Mellenthin could scarcely imagine. In the Wehrmacht, such waste would have resulted in court-martial proceedings. Here, it appeared to be standard operating procedure. The general returned to his journal, dipping his pen in the inkwell and resuming his observations. "The rubber situation here defies comprehension," he wrote. "Since my arrival, I have witnessed supply operations that would have been impossible in the German military even at the height of our power in 1940. The Americans operate their entire logistics system on wheels, every vehicle equipped with tires that appear to have unlimited life expectancy because they are replaced long before reaching the end of their useful service. Yesterday I learned from a conversation with one of the guards that the camp receives a delivery of new tires every 3 days. This single prisoner of war camp consumes more rubber in a month than an entire German panzer division received during our final year in North Africa. The implications for the broader war are clear and devastating. If this abundance extends throughout the American military establishment, and I have every reason to believe it does, then the material foundation of their victory was assured long before the first major battles were fought. What General von Mellenthin could not know, sitting in his Mississippi barracks in late 1944, was that he was witnessing merely a tiny fragment of the most dramatic industrial transformation in modern history. The tires rolling past his window represented the output of an industry that had barely existed 3 years earlier, a synthetic rubber program that had grown from essentially nothing to become one of the decisive factors in the Allied victory. The very concept of creating rubber from petroleum and agricultural products, while theoretically understood by chemists in both Germany and America, had been transformed from laboratory curiosity to industrial reality with a speed that would have seemed impossible to any observer in 1941. The German High Command had spent years analysing the global rubber situation, mapping every plantation in Southeast Asia, calculating precisely how much natural rubber the British and Americans would lose when Japan conquered the resource-rich territories of Malaya, Sumatra and Java. Those calculations had been meticulous, thorough, and seemingly irrefutable. They had also been rendered completely irrelevant by an industrial mobilization that German planners had never imagined possible. The story of that mobilization had begun in Berlin, in the austere planning rooms of the Wehrmacht High Command, where senior officers gathered around tables covered with maps marked with coloured pins representing strategic resources. General Franz Halder, serving as Chief of the General Staff, had been among the first to recognise the potential vulnerability of Allied rubber supplies. On February 15, 1942, 2 days after British forces surrendered Singapore to the Japanese, Halder made an entry in his personal diary that reflected the confident assessment shared by most German military planners. The British and Americans have now lost approximately 90% of the world's natural rubber production, he wrote in his neat, methodical hand. Without access to the rubber plantations of Southeast Asia, the Anglo-American forces will face a crisis of supply that cannot be overcome through increased production from the limited sources that remain available to them. Rubber is not merely a convenience in modern warfare, it is an absolute necessity. Without rubber, there can be no tyres. Without tyres, there can be no trucks. Without trucks, there can be no mobile warfare of the type that has defined this conflict. The arithmetic is inescapable, and it strongly favours the Axis powers. Halder's analysis was based on solid intelligence and reasonable assumptions. The Japanese conquest of Malaya and the Dutch East Indies had indeed captured approximately 95% of global natural rubber production. The sprawling plantations that had supplied the Western powers for decades were now firmly under Japanese control, and the British naval blockade that had so effectively strangled German trade now worked against the Allies themselves. American strategic planners had anticipated this problem and built up a stockpile of natural rubber, but intelligence reports indicated that stockpile contained approximately 578,000 tons. German analysts calculated that at American consumption rates, this stockpile would last 18 months at absolute maximum, and probably less given the expansion of American military operations. After that, the United States would face a rubber famine that would cripple its ability to conduct mechanized warfare. German vehicles might be running on retreaded tyres and makeshift substitutes, but at least Germany had a functioning synthetic rubber industry, however limited its output. The Americans, German intelligence believed, would have virtually nothing. What General Halder did not know, what German intelligence had completely failed to detect, was that even as he wrote those confident words in his diary, American engineers were already breaking ground on a network of synthetic rubber plants across the continental United States. The Rubber Reserve Company, established by presidential order in 1940, had begun planning for exactly this contingency long before Pearl Harbor brought America into the war. By the time Singapore fell and Japanese forces secured the rubber plantations of Southeast Asia, construction was already well underway on facilities that would transform petroleum and grain alcohol into synthetic rubber on a scale that German planners considered impossible. The American government had mobilized resources, coordinated competing private companies, and launched an industrial program that would eventually dwarf anything Germany had achieved in this field, and would do so in a fraction of the time that German synthetic rubber development had required. The magnitude of this transformation becomes clear when examining the baseline from which America started. Before December 1941, synthetic rubber represented less than 0.5% of American rubber consumption. The nation's rubber needs were met almost entirely through imports of natural rubber from Southeast Asia, supplemented by smaller quantities from Africa and South America. The four major American tire manufacturers, Firestone, Goodyear, B.F. Goodrich, and U.S. Rubber, had conducted research into synthetic alternatives, but this work had been limited, underfunded, and viewed primarily as insurance against future supply disruptions, rather than as an urgent military necessity. Total American production of synthetic rubber in 1941 amounted to just 230 tons, an amount so small it could barely outfit a single armoured division with tyres for its vehicles. German intelligence analysts, aware of these figures through pre-war industrial espionage and published trade statistics, had every reason to believe that the United States could not possibly develop a meaningful synthetic rubber industry before 1945 at the earliest, and probably not even then. They were wrong in ways that would prove catastrophic to German war aims. On December 19, 1941, exactly 12 days after Japanese aircraft struck Pearl Harbor and brought America into the war, something unprecedented occurred in American industrial history. The presidents of Firestone, Goodyear, Goodrich, and U.S. Rubber, men who had spent their entire careers as fierce competitors locked in battles for market share and technological advantage, gathered in Washington with government officials to discuss the rubber crisis. These were not friendly men. Their companies had fought bitter patent battles, engaged in aggressive competition for customers, and guarded their technical secrets with fanatic intensity. Trade secrets that represented millions of dollars of research investment were considered more valuable than gold, protected by elaborate security measures and defended in court with armies of lawyers. Yet in a single day of meetings, these men agreed to share everything. Every patent, every formula, every production technique, every bit of technical knowledge accumulated over decades of research would be made available to all companies without restriction or compensation. Engineers from Firestone would work inside Goodyear plants. Chemists from Goodrich would share their formulas with researchers at U.S. Rubber. Technical information that would normally be protected as proprietary would be distributed freely across the entire industry. This cooperation was not entirely voluntary. The government made clear that companies unwilling to participate fully would be nationalized and their facilities taken over by direct government operation. But the remarkable fact was that once the decision was made, the cooperation became genuine and wholehearted. Executives who had viewed each other as enemies suddenly found themselves working as partners toward a common goal. This transformation was something that German military minds, accustomed to the rigid hierarchies and jealous territoriality of German industrial firms, could barely comprehend. In Germany, getting Krupp to share technical information with Thyssen would have been unthinkable. The idea of IG Farben making its proprietary chemical processes available to competing firms would have been dismissed as fantasy. The Nazi system proclaimed the virtues of leadership and unified command, yet it could not achieve the kind of genuine industrial cooperation that democratic America accomplished in a matter of days. Among the first German officers to encounter evidence of American rubber abundance were those captured during the North African campaigns of 1942 and 1943. The defeat of Axis forces in North Africa represented a catastrophe of immense proportions, with over 150,000 German and Italian troops taken prisoner, including 12 German generals and numerous other senior officers. These men had fought across the deserts of Libya and Egypt, watching as their mechanized forces gradually lost the mobility that had been their greatest advantage. General der Panzertruppe Gustav von Fürst, who commanded the 5th Panzer Army until its surrender on May 9, 1943, had spent his final months of command watching his vehicle strength decline, not primarily due to enemy action, but due to simple lack of spare parts, especially tires. Colonel General Hans-Jürgen von Arnim, commander of Army Group Africa, surrendered on May 12 after his forces literally ran out of fuel and tires simultaneously, leaving his units immobilized and helpless. General der Panzertruppe Wilhelm Ritter von Thoma, the legendary tank commander who had led the Afrika Korps, had been captured much earlier at El Alamein on November 4, 1942, after his command tank was hit repeatedly and left burning. Von Thoma had stood quietly amid the wreckage of his command, waiting calmly as British forces took him prisoner, displaying the stoic dignity expected of a German general even in defeat. These captured generals and their staffs were initially held at interrogation facilities in North Africa and then in England, where they were carefully questioned about German military capabilities, strategic intentions, and technical developments. The Special Interrogation Centre at Trent Park in England proved particularly productive, not through harsh interrogation techniques, but through sophisticated electronic surveillance. German officers held there were allowed to associate freely with each other, and their conversations were recorded by hidden microphones. Von Thoma, in conversations with fellow prisoners that he believed were private, made revealing comments about the rubber situation that had contributed to German defeat in North Africa. "We calculated everything precisely," he told other generals during one recorded conversation. "We knew British tank strength. We understood their tactical doctrines. We anticipated their strategic responses. What we did not anticipate, what we could not have imagined, was their ability to create resources from nothing. The British received unlimited supplies from America, including rubber that somehow materialized despite the loss of all the Asian plantations. Our intelligence assured us they would run out. They never did. We ran out of everything while fighting enemies who seemed to have unlimited supplies of everything." The journey from capture in North Africa to imprisonment in America proved revelatory for these German officers in ways that mere interrogation could never achieve. They were transported across the Atlantic in Liberty ships and then moved by rail from American ports to prison camps scattered across the southern and southwestern United States. The rail journey itself provided the first shocking glimpse of American industrial capacity. These were not cattle cars of the type used to transport Soviet prisoners, nor were they basic military transport vehicles. German officers found themselves riding in passenger coaches with padded seats upholstered in rubber-backed fabric, windows sealed with rubber gaskets, and electrical systems insulated with rubber compounds. Every detail of the trains spoke to rubber abundance that seemed impossible to men who had spent the last years fighting with vehicles mounted on worn tires patched beyond any reasonable standard of safety. Lieutenant General Karl Bulovius, a corps commander captured with Army Group Africa, kept detailed notes during the 3-day train journey from Norfolk, Virginia to his ultimate destination at a camp in Mississippi. "Every mile we travelled revealed abundance beyond our comprehension," he wrote in the small notebook he was permitted to keep. At Richmond we passed what the guard informed me was a tyre manufacturing facility. Thousands upon thousands of tyres were stacked in the open yard like cordwood, enough tyres to equip an entire army group. I asked the guard how long it had taken to accumulate such stockpiles, thinking perhaps this represented months or years of production. He laughed and told me this was one day's output from a single production line, and the factory operated 12 production lines continuously. In Tunisia, my entire division received 50 tyres over a period of 3 months, and we considered ourselves fortunate to receive even that many. Here, one factory produces in a single day more tyres than we received for an entire armoured division in half a year. The psychological impact of this abundance began the moment these officers arrived on American soil and intensified with every subsequent observation. General der Infanterie Theodor von Sponeck, commander of the 90th Light Division, who had surrendered to New Zealand forces in Tunisia, was processed through the port at Norfolk and later wrote detailed impressions of that experience in letters that were intercepted and never delivered. The dock workers wore shoes with thick rubber soles, far better footwear than most German soldiers possessed, he noted. Their rain gear was rubberized fabric that repelled water completely. The cranes lifting cargo from ships operated on enormous rubber tires, not the steel wheels we would have used. Even the hand trucks used to move individual packages had rubber wheels. Everything involving movement or protection from the elements employed rubber in quantities we could never have imagined. In Russia, our army had been forced to return to horse-drawn transport because we simply had no tires for our vehicles. Here in America, they put rubber on everything, even on equipment used for the most mundane civilian purposes. German prisoners who were assigned to work details in agricultural areas or at military installations often passed close to the new synthetic rubber facilities that were rising across the American landscape. The scale of these plants exceeded anything in German industrial experience. The Firestone facility in Akron, Ohio, employed more than 15,000 workers and operated around the clock in continuous shifts. The B.F. Goodrich plant at Port Neches, Texas, sprawled across 600 acres of land, an industrial complex larger than many German towns. The government-owned facility at Institute, West Virginia, produced 90,000 tons annually from a single site, nearly matching Germany's entire national output at its peak from just one facility. Colonel Hans-Georg Hildebrandt, a supply officer from the 21st Panzer Division who had been captured in North Africa, found himself assigned to a work detail that delivered agricultural supplies to farms near the massive synthetic rubber complex at Baton Rouge, Louisiana. His observations, recorded in letters home that were confiscated and never sent, provide remarkably detailed technical insights into American capabilities. The plant operates using the Buna-S process, essentially the same fundamental chemistry that we developed and used in Germany, Hildebrandt wrote with the precision of an engineer examining a technical problem. But the scale of operations is beyond anything I can adequately describe. The facility has 4 complete production lines operating simultaneously, each capable of producing 300 tons daily. Our Schkopau plant, which was the pride of German chemical engineering and which took 4 years from groundbreaking to initial production, produces 140 tons daily at absolute maximum capacity. This single American facility, which I was informed was constructed in 9 months from start to full operation, produces more synthetic rubber in a single day than our most advanced plant produces in a week. The implications are staggering. If this facility is representative of American production capacity, and I have no reason to believe it is unique, then the United States is producing synthetic rubber at a rate that exceeds our total national production by perhaps 10 or 15 times. The speed of American plant construction represented a particular shock to German engineering expectations and assumptions. In Germany, the Schkopau plant had required 4 full years from initial groundbreaking to the achievement of full production capacity, and this was considered a remarkable achievement by German standards. The construction had been undertaken by IG Farben, the most technically advanced chemical company in the world, with unlimited access to German engineering expertise and government support. The plant had been designed with meticulous care, every system carefully engineered to German specifications, every safety protocol thoroughly planned and implemented. Yet despite all these advantages, bringing the facility from concept to full operation had required 4 years of intensive work. The Hüls plant near Recklinghausen had taken 3 years and achieved maximum output of 30,000 tons annually. The Ludwigshafen facility had required 5 years of construction and produced just 15,000 tons at peak capacity. Total German synthetic rubber production from all facilities combined had peaked at approximately 120,000 tons in 1943, and despite desperate efforts to increase output, production never exceeded this figure and in fact began declining in 1944 as Allied bombing disrupted operations and raw material shortages became critical. American plants, by contrast, were going from groundbreaking to full production in 9 to 12 months, and individual facilities routinely matched or exceeded half of Germany's total national production. This was not a matter of American engineers being smarter or more capable than their German counterparts. German chemical engineering was world-class, possibly the best in the world in 1940. What made the difference was resources, organisation, and above all, the complete cooperation between government, industry, and labour that characterised the American war effort. In Germany, even as the nation fought for survival, industrial firms competed jealously for resources, government agencies worked at cross purposes, and the Nazi Party hierarchy inserted itself into technical decisions with disastrous results. In America, competing private companies worked together as if they were divisions of a single firm. Government coordination proved remarkably efficient despite the apparent chaos of democratic debate, and workers genuinely believed they were contributing to a righteous cause worth their maximum effort. The German military had entered the war in 1939 with approximately 600,000 motor vehicles of all types, from motorcycles to heavy trucks. The invasion of Poland had been conducted with approximately 2,700 tanks and 110,000 trucks, a level of mechanization that exceeded any previous military force in history. By the time Operation Barbarossa launched against the Soviet Union in June 1941, the Wehrmacht fielded roughly 3,300 tanks and 6 100,000 motor vehicles in total. These vehicles represented the mechanized striking power that had made Blitzkrieg possible, enabling rapid movements that overwhelmed enemy forces before they could organize coherent defense. But mechanized warfare required constant maintenance and steady supplies of spare parts, and the most critical spare part was tires. Each vehicle required multiple tires, and under combat conditions those tires wore out rapidly. On paved roads under ideal conditions, a military truck tire might last 20,000 kilometers. On unpaved roads, in mud or sand, or under combat conditions with heavy loads and high speeds, that same tire might last 5,000 kilometers or less. Simple arithmetic revealed the scale of the German problem. 600,000 vehicles, each requiring multiple tires, with replacement needed every few months under combat conditions, meant Germany needed approximately 6 million tires annually, just to maintain existing vehicle strength, not counting new vehicle production or the creation of new units. Yet German synthetic rubber production, despite starting as early as 1936 with IG Farben's world-leading chemical expertise driving development, could never meet this demand. The Schkopau plant, the Hüls facility, the installations at Ludwigshafen, and the smaller plants at Leverkusen and Hanover collectively managed to produce approximately 350,000 tons of synthetic rubber throughout the entire war. This sounds like a substantial quantity until one calculates how many tires can be produced from that amount of rubber and compares it to German military requirements. Including natural rubber imports, which were cut off almost entirely by the British naval blockade by 1941, and captured stocks from conquered territories like France, Belgium and the Netherlands, which provided temporary relief but were exhausted by 1942, Germany could produce perhaps 2 million tires annually at peak capacity. The Wehrmacht needed 6 million tires just for replacement purposes, not counting new vehicle production or the expansion of mechanized units that German strategic doctrine demanded. The arithmetic was brutal and inescapable. Germany could produce 1/3 of the tires it actually needed. This meant that from 1942 onward, the German military was engaged in a losing battle against basic physics and chemistry, cannibalizing tires from disabled vehicles, mounting trucks on steel rims wrapped with rope or wooden blocks, and reverting increasingly to horse-drawn transport. The proud panzer divisions that had conquered France in 6 weeks during the spring of 1940, racing across the countryside in a display of mechanized warfare that revolutionized military thinking, were by 1943 increasingly immobilized, not by enemy action, but by tire failure and the lack of replacements. General Oberst Heinz Guderian, the architect of Blitzkrieg doctrine and one of the most innovative military minds of the 20th century, had experienced this crisis firsthand during the invasion of the Soviet Union. His 2nd Panzer Army had entered Russia in June 1941 with 1,000 tanks and 14,000 vehicles of various types, representing one of the most powerful mechanized forces ever assembled. By December 1941, after just 6 months of continuous campaigning, the 2nd Panzer Army was operating at 21% of its original vehicle strength. More than 3/4 of Guderian's transport capacity had been lost in half a year. In a brutally honest report submitted to the High Command, Guderian wrote words that were suppressed and never widely circulated because they contradicted the official narrative of German invincibility. "We are losing more vehicles to mechanical failure and lack of spare parts than to enemy action," Guderian reported. "The Russian winter destroys rubber, turning it brittle and causing it to crack and fail. The Russian mud tears tires apart. Russian roads, or what pass for roads, wear through tread in a fraction of the time we calculated. And we have no replacements. My panzer divisions are becoming infantry divisions by default, not by strategic choice, but by simple lack of the rubber necessary to keep vehicles mobile." The situation in North Africa proved even more desperate in some respects, because every spare part, including tires, had to be shipped across the Mediterranean Sea under constant attack from British air and naval forces. Major Friedrich Schulze, serving as logistics officer with the Africa Corps, maintained detailed records that survived the war and provide stark documentation of the rubber crisis. His entry for November 1942, written just weeks before the final defeat at El Alamein, painted a picture of desperation that no amount of tactical brilliance could overcome. Received allocation of 50 new tyres for entire division, Schulze recorded. We have over 300 vehicles requiring immediate tyre replacement just to remain operational. Combat vehicles have absolute priority for the few tyres we receive. Supply trucks are operating on steel bands welded directly to wheel rims because we have no tyres at all. Maximum speed is reduced to 12 kilometers per hour, meaning supply runs that should take 2 hours require 6 hours or more. Ammunition deliveries are taking 3 times as long as planned. Water shipments are delayed catastrophically. Yesterday, 3 men died of thirst in forward positions because the water truck assigned to their sector broke down and the replacement vehicle could not reach them in time because it is operating on steel rims that damage the vehicle further with every kilometre travelled. General der Panzertruppe Ludwig Kruvel, who had commanded the Afrika Korps before his capture in May 1942 when his observation aircraft was shot down over British lines, understood better than most the mathematics of defeat that had nothing to do with tactical skill or strategic brilliance. From his confinement at Camp Shelby, where he was among the most senior German officers held in America, Kruvel maintained a secret diary that he successfully concealed from camp authorities. His entries from late 1944, written after he had spent more than 2 years observing American industrial capabilities, reflect the bitter recognition of truths that German propaganda would never acknowledge. We lost in Africa not to superior generalship, though British commanders were certainly competent, and not to inferior soldiers, for German troops fought magnificently even in defeat, Kruvel wrote. We lost to logistics, to the simple fact that every German vehicle required tyres that had to be shipped from Europe across the Mediterranean under constant attack, while every American and British vehicle operated on tyres manufactured in unlimited quantities either in Britain or America. The Allies could afford to be wasteful with their resources, discarding equipment that we would have repaired and reused. We could not afford to lose a single tyre, yet we lost them constantly. The mathematics of the situation made defeat inevitable regardless of tactical skill or operational brilliance. The American synthetic rubber program represented organizational genius of a type that German military minds, trained to admire order and hierarchy, struggled to comprehend fully. In Germany, synthetic rubber production was monopolized by IG Farben, the chemical giant that had pioneered the technology and jealously guarded its patents and production methods against any potential competition. Different divisions within IG Farben itself operated as competing fiefdoms, barely cooperating even when cooperation would have benefited the company overall. The German military, despite being the primary customer for synthetic rubber, had to negotiate with IG Farben for every modification to rubber formulas, every increase in production targets, every authorization to construct new facilities. The relationship was simultaneously symbiotic and antagonistic, with IG Farben executives viewing military officers as customers to be managed rather than partners in a common cause, while military officers viewed IG Farben as an obstacle to be navigated rather than an ally committed to victory. In America, the approach was entirely different, and the contrast illuminated fundamental differences between democratic and authoritarian systems. On December 19, 1941, the presidents of Firestone, Goodyear, Goodrich, and U.S. Rubber met in Washington with government officials for emergency consultations about the rubber crisis that Japanese conquests had created. These men represented companies that had spent decades as mortal enemies, fighting brutal battles for market share, engaging in industrial espionage against each other, and protecting their technical secrets with almost paranoid intensity. Patents that represented millions of dollars of research investment were routinely the subject of lawsuits that dragged through courts for years. Technical innovations were guarded more carefully than military secrets. Yet in a single day of intense negotiations, these executives agreed to share absolutely everything. Every patent would be made available to all companies without compensation. Every technical innovation, every production method, every bit of accumulated expertise would be shared freely. Engineers from Firestone would work directly in Goodyear plants, and vice versa. Chemists from Goodrich would share their most valuable formulas with researchers at US Rubber without restriction. Customer lists, market research, even strategic business plans would be made available to former competitors who were now partners in a common cause. General der Infanterie Günther Blumentritt, who had served as Chief of Staff to Field Marshal von Rundstedt in France and was captured during the Allied breakout from Normandy, learned about this cooperation during his internment at Camp Forest in Tennessee. An American officer, making casual conversation, explained how the synthetic rubber program operated. Blumentritt, whose English was excellent thanks to time spent in England before the war, asked careful questions and took mental notes that he later recorded in his diary. The American officer explained that competing companies had become partners almost overnight, sharing everything including trade secrets worth fortunes. Blumentritt later wrote about this conversation with an amazement that comes through clearly in his words. Lifetime competitors became full partners in less than a day, he recorded. The government gave them a clear choice: cooperate completely and voluntarily, or face nationalization of their facilities and loss of all control. They chose cooperation, and the cooperation appears to have been genuine and wholehearted rather than reluctant compliance. In Germany, getting Krupp to share technical information with Thyssen would be absolutely impossible under any circumstances. The companies would fight such a requirement through every legal channel, and if forced to comply, they would do so grudgingly and incompletely, sharing the minimum possible while protecting their most valuable secrets. Getting IG Farben to share proprietary chemical processes with potential competitors would require years of political maneuvering at the highest levels of government, and even then success would be uncertain. Yet here in America, democratic America that we were taught to view as weak and chaotic, competing capitalist firms achieved in days what authoritarian Germany could not accomplish in years. The technological achievement represented by the American synthetic rubber program proved equally impressive to German technical officers who had sufficient background to understand what had been accomplished. The basic chemistry of synthetic rubber, specifically the polymerization of butadiene with styrene to create what chemists called Buna S rubber, was well understood by scientists in both Germany and America before the war began. German chemists at IG Farben had pioneered much of this work during the 1920s and 1930s, developing the fundamental processes and creating the first commercially viable synthetic rubber. American chemists had followed German developments closely, sometimes through legitimate scientific exchange and sometimes through industrial espionage, and understood the theoretical basis of synthetic rubber production. But theoretical knowledge and industrial production were separated by an enormous gulf. Transforming laboratory procedures that produced grams of material into industrial processes that produced thousands of tons required solving literally thousands of individual engineering problems, from maintaining precise temperature control in enormous reaction vessels to achieving consistent polymerization across massive volumes of material to developing quality control procedures that ensured uniform product specifications. German engineers had struggled for years with fundamental issues. Controlling the polymerization process to achieve consistent molecular weights proved extraordinarily difficult at industrial scales. Catalyst systems that worked perfectly in laboratory glassware behaved unpredictably in tanks containing tons of material. Achieving proper mixing in reaction vessels hundreds of times larger than laboratory equipment required sophisticated engineering that took years to develop. Quality control presented additional challenges, as synthetic rubber could vary dramatically in properties depending on subtle variations in processing conditions. Temperature fluctuations of just a few degrees could ruin entire batches of material. Pressure variations could result in rubber with completely different characteristics than desired. German facilities achieved perhaps 70% yields from their raw materials in optimal conditions, with substantial quantities of material being lost to side reactions or processing failures. American engineers, backed by unlimited financial resources and freed entirely from patent restrictions that would have prevented sharing of technical knowledge, solved these problems in months rather than years. They developed continuous polymerization processes, where raw materials flowed constantly through the system rather than being processed in individual batches, achieving yields that exceeded 95% compared to Germany's 70%. This improvement alone represented an enormous advantage in efficiency and resource utilization. They created sophisticated catalyst systems that operated at lower temperatures and pressures than German processes, dramatically reducing energy requirements and making the facilities safer to operate. Most impressively, they solved the problem of molecular weight distribution that had plagued German synthetic rubber efforts for more than a decade. German Buna rubber exhibited wide variations in molecular weight, resulting in material that had inconsistent properties and performed unpredictably under different conditions. American chemists, working collaboratively across company boundaries, developed methods to control polymerization that produced synthetic rubber with narrow molecular weight distributions and highly consistent properties. Dr. Wilhelm Krauch, a chemist from IG Farben who had been working at the company's facilities in France when Allied forces advanced through the region, was captured and interned at Camp Blanding in Florida. Through conversations with camp guards, some of whom had worked in the petrochemical industry before being drafted into military service, Krauch learned technical details that astounded him and challenged his assumptions about American technical capabilities. His diary entries from this period reflect genuine amazement at what Americans had achieved. They described continuous flow reactors operating at scales we had deemed impossible to control properly, Krauch wrote. They had completely solved the problem of polymer branching that limited tire life in our synthetic rubber, an issue our best chemists had worked on for years without achieving a satisfactory solution. They had developed chemical modifiers that dramatically improved low-temperature flexibility, allowing their synthetic rubber to remain pliable under conditions where our Buna rubber became brittle and fractured. Most remarkably, they achieved all this while simultaneously sharing every discovery between competing companies. In Germany, such sharing would be considered industrial treason. Our entire system was built on protecting proprietary knowledge, yet the Americans achieved better results faster by sharing everything. The Firestone Company produced the very first bale of American synthetic rubber on April 26, 1942, less than 5 months after Pearl Harbor brought America into the war. Goodyear followed closely behind on May 18th. U.S. Rubber achieved production on September 4th, and Goodrich joined the program on November 27th. By the end of 1942, the first full year of American involvement in the war, these pioneering plants had produced 3,721 tons of synthetic rubber. This quantity was still modest compared to requirements, barely scratching the surface of American military needs, but production was ramping up exponentially as new facilities came online and existing plants increased capacity. In 1943, total American synthetic rubber production reached 230,000 tons, a 60-fold increase over the previous year. By 1944, production had more than tripled again to 770,000 tons. By 1945, annual production approached 920,000 tons, with 85% of this total being GRS, or government rubber styrene, the standardized synthetic rubber formulation that had been developed through the Collaborative Research Program. Total American wartime production from 1942 through 1945 exceeded 2 million tons, an amount that exceeded total German production over the same period by roughly 6 to 1. The quality of American synthetic rubber proved superior to German Buna rubber in virtually every measurable characteristic, a fact that German technical officers found particularly galling given Germany's early lead in synthetic rubber development. German Buna rubber was significantly less elastic than natural rubber, making it unsuitable for many applications without extensive modification. It proved more prone to heat degradation, breaking down when exposed to high temperatures that natural rubber could withstand easily. Most critically for military use, German synthetic rubber wore much faster than natural rubber, resulting in tyres that required replacement far more frequently. German military vehicles required specially formulated tyres that carefully balanced synthetic and natural rubber content, attempting to gain the availability of synthetic material while maintaining the performance characteristics of natural rubber. Even these carefully engineered tyres lasted perhaps 5,000 miles under good conditions on paved roads and substantially less in combat conditions or on unpaved surfaces. American synthetic rubber, particularly after the development of cold rubber processing techniques in 1943, created tyres that actually lasted longer than natural rubber tyres and performed better under a wider range of conditions. Major Hans Weber, an engineer from the German Army High Command's Technical Division who had been captured during the Battle of the Bulge, learned about these advances while held at Camp McCain in Mississippi. Through conversations with American technical personnel working at the camp and with guards who had previously worked in the rubber industry, Weber gathered information about improvements that German researchers had been attempting to achieve for years. He recorded these conversations in his diary with the precision of a trained engineer. They developed carbon black formulations that increased tyre life by 300% compared to earlier formulations, Weber wrote. They created synthetic rubber compounds that remained flexible and functional at temperatures as low as -40 degrees Celsius, temperatures at which our Buna rubber became brittle and shattered like glass. They completely solved the ozone cracking problem that caused our tyres to deteriorate rapidly even when not in use, meaning their tyres could be stored for extended periods without degradation. Each of these advances represented years of research effort by German chemists working with limited resources. The Americans achieved all of them simultaneously within months by pooling research across the entire industry. The human dimension of the American industrial mobilization represented perhaps the most profound contrast with German practices and the aspect that challenged Nazi ideology most directly. German synthetic rubber plants relied heavily on forced labor from concentration camps and conscripted foreign workers who had no interest in German victory and often actively sabotaged production when they could do so without being caught. Workers operated under constant threat of punishment, with no motivation beyond avoiding consequences for failing to meet quotas. The system was brutally efficient in the short term, but fundamentally unstable and inefficient over longer periods. Sabotage was endemic. Quality suffered because workers had no incentive to care about their output, and technical problems persisted because workers who might have noticed solutions had no reason to bring them to management's attention. American plants operated on entirely different principles that reflected fundamental differences in social organization. At the Port Neches facility in Texas, workers earned wages that would have made them prosperous by German standards, enough to afford automobiles, comfortable housing, and abundant food. They lived in newly constructed housing developments with modern amenities, including electric appliances, indoor plumbing with hot water, and in many cases their own automobiles purchased with their wages. Workers received substantial bonuses for exceeding production targets, creating genuine financial incentives to maximize output and improve efficiency. The plants implemented suggestion programs where workers could propose improvements to processes or procedures, with successful suggestions rewarded with cash bonuses and public recognition. This created a virtuous cycle where workers actively looked for ways to improve operations because they benefited directly from improvements. Colonel Hermann Feyerabend, a Wehrmacht transportation officer captured during the Ardennes offensive, witnessed this system firsthand when his prison work detail was assigned to deliver supplies to a synthetic rubber plant in Louisiana. The contrast with German industrial practices struck him immediately and forcefully. The workers displayed enthusiasm I had never witnessed in German factories, even in plants producing critical war materials, Feyerabend wrote in letters home. They had production charts mounted prominently on walls, showing daily output for each shift and each production line. When a shift exceeded its target, they celebrated with genuine joy, as if they had achieved a personal triumph rather than simply fulfilled their assigned duties. I observed a female worker, perhaps 20 years old, operating monitoring equipment more sophisticated than anything I had seen in German chemical plants. She checked gauges, adjusted valves, recorded data, all with obvious competence and confidence. The guard informed me she earned more in a single week than a German army captain earned in a month. This seemed impossible, yet I had no reason to doubt it. The racial dimensions of American war production proved particularly devastating to Nazi racial ideology and the assumptions it had fostered among German military officers. German officers discovered that many synthetic rubber plants employed African American workers in skilled technical positions, not just as menial laborers, but as operators of complex equipment and supervisors of production processes. Women operated machinery that in Germany would have required engineers with advanced degrees to operate safely. Most remarkably to German observers, many of the chemists and researchers driving innovations in synthetic rubber technology were Jewish refugees from Nazi Germany who had fled persecution in Europe and found opportunities in America. These were the very people that Nazi ideology had declared incapable of creative technical work, the people who had been driven from German universities and research laboratories, now leading the technical efforts that were producing rubber superior to anything Germany could manufacture. SS Brigadeführer Kurt Meyer, commander of the 12th SS Panzer Division Hitlerjugend, captured in Belgium in September 1944 after his division was destroyed during fighting around Falaise, encountered this reality directly upon arrival at Camp Clinton. Despite years of intensive ideological indoctrination that had emphasized supposed racial hierarchies and Aryan superiority in technical matters, the evidence before Meyer's eyes was undeniable and impossible to rationalize away. His comments to camp interrogators, carefully recorded in intelligence reports, reveal the cognitive dissonance created when ideology confronted reality. A Negro sergeant explained the synthetic rubber production process to members of our work detail, Meyer stated during one interview. He understood the chemistry involved better than most German officers I had known, discussing polymerization rates and catalyst efficiency with obvious expertise. Women operated complex machinery that in Germany would require doctorate-level education to understand properly. The plant manager, I learned through conversation, was Jewish, a refugee who had escaped from Berlin in 1938. These were people that our ideology taught us to consider inferior, yet they had created an industrial system that our supposed master race could not approach despite years of effort by our best chemists and engineers. The contradiction cannot be dismissed or explained away. Rubber's importance extended far beyond tires, though tires represented the most visible and quantifiable aspect of the problem. Every aspect of mechanized warfare depended on rubber components. Engine gaskets and seals required rubber that could withstand high temperatures and exposure to petroleum products. Fuel hoses needed rubber that wouldn't degrade when in constant contact with gasoline or diesel fuel. Electrical systems relied on rubber insulation to prevent short circuits. Aircraft required countless rubber components, from engine seals to control cable housings to pneumatic systems. Perhaps most critically, aircraft fuel tanks needed self-sealing rubber bladders that could prevent catastrophic fires when minor battle damage occurred. German ersatz, substitutes for rubber, created from whatever materials could be found when actual rubber became unavailable, proved inferior in virtually every application. Fuel hoses made from substitute materials leaked constantly, causing fires and explosions that killed crews and destroyed equipment. Gaskets manufactured from compressed paper or other substitutes failed rapidly, leading to engine breakdowns and mission cancellations. Electrical systems using cloth insulation instead of rubber insulation short-circuited when exposed to moisture, a common occurrence in combat conditions. German aircraft lacking self-sealing fuel tanks turned minor battle damage into catastrophic disasters, as any hit to a fuel tank resulted in massive fires that no crew could survive. General Lieutenant Adolf Galland, who had commanded the Luftwaffe fighter forces and was among the most respected combat pilots in the German military, understood these implications better than most despite not being captured until the war's final days. In his post-war writings, Galland documented how material shortages had undermined German air power at least as much as numerical inferiority or tactical mistakes. Our fighters leaked fuel continuously because we lacked rubber for proper sealing, Galland wrote. Every flight began with fuel tanks full and ended with substantially less fuel than calculations indicated should remain, the difference having leaked away during flight. Our bombers caught fire from battle damage that Allied aircraft would have survived easily because we lacked self-sealing tanks. Our engines failed constantly because ersatz gaskets could not maintain proper compression or sealing. We lost as many aircraft to material failures as to direct enemy action. Meanwhile, American aircraft featured rubber components in such abundance that they could sustain battle damage that would have destroyed German aircraft and still return safely to base. By mid-1944, American synthetic rubber production had reached such extraordinary levels that civilian tire rationing, which had been strictly enforced since early 1942, could begin to be relaxed. This development, reported in American newspapers that circulated in prisoner of war camps, had profound psychological impact on German officers who could compare it to the increasingly desperate situation in Germany. While German civilians walked on wooden clogs because leather and rubber were reserved exclusively for military use, American civilians were beginning to receive new tires for personal automobiles. German prisoners working on American farms under the camp labor program witnessed this abundance directly. Oberst Friedrich Zimmermann, a supply officer captured in Normandy, was assigned to work on a farm in Iowa and recorded his observations in letters that were carefully screened by camp authorities. The farmer owns 3 automobiles, Zimmermann wrote. 3 automobiles for a single family. Each automobile sits on new tires. His wife drives one automobile to town for shopping. His son drives another to school. The farmer himself uses a truck for farm work. All these vehicles operate on rubber tires that appear to be replaced regularly long before they are worn out. Meanwhile, in Germany, my colleagues are mounting military trucks on steel rims because we have no rubber at all. The contrast could not be more stark or more devastating to morale. The Battle of the Bulge, launched in December 1944 as Germany's last major offensive operation in the West, exemplified the material constraints under which German forces now operated. The offensive began with vehicles already at the absolute limit of mechanical reliability, running on tires patched far beyond any reasonable standard of safety. German logistics plans assumed, quite accurately, that captured American supply dumps would be essential to sustaining the offensive because German logistical capacity could not deliver adequate supplies through conventional channels. When German forces did capture American supply installations, they discovered material abundance that seemed like pure fantasy to soldiers who had been fighting on the edge of starvation and mechanical failure. Colonel Hans von Luck, commanding a battle group during the offensive, recorded his impressions of a captured American supply dump. "We found more new tires in this one depot than my entire regiment had received in the previous year," von Luck wrote. There were boxes of spare parts, mountains of rations, jerry cans full of fuel, all simply sitting in organized rows, waiting to be used. We had been taught that American logistics were inefficient and wasteful. What we saw was organization and abundance on a scale we could barely comprehend. German officers in American captivity followed the battle's progress through newspapers and radio broadcasts, understanding far better than most the material constraints under which their comrades were fighting. They knew German vehicles in the Ardennes were running on tires patched beyond safe use, that fuel trucks could not maintain supply lines because worn tires could not handle winter road conditions. General der Panzertruppe Hasso von Manteuffel, who commanded 5th Panzer Army during the Ardennes offensive and was captured after the battle's failure, would later testify about the material situation. "We launched our offensive with vehicles already at the absolute margin of mechanical reliability," von Manteuffel stated during post-war interrogations. Tire supplies were so critical that we assigned special recovery teams whose sole mission was salvaging tires from destroyed vehicles, whether German or American. When we captured American supply dumps, one depot contained more new tires than my entire army had received over the previous 6 months. It was simultaneously inspiring and devastating, proof that we were fighting enemies who possessed material resources we could never hope to match. The officers in American camps witnessed something else that winter that brought home the full extent of American material superiority. American forces in Europe were so abundantly supplied with rubber and other materials that they could afford what Germans considered incredible wastage. Reports from the European theatre described American units abandoning vehicles with minor mechanical problems because requisitioning new vehicles was simpler and faster than organizing repairs. Trucks with flat tires were sometimes left by the roadside because it was more efficient to request replacement vehicles than to spend time changing tires. This practice, which would have resulted in immediate court-martial for any German officer, was apparently standard procedure for American units focused on maintaining operational tempo rather than preserving equipment. General der Infanterie Baptist Ness, commander of the 85th Infantry Division captured during the final collapse in the Ruhr Pocket, observed the psychological impact of these reports. American newspapers reached our camp regularly, and we read them carefully for information about the war's progress, Ness wrote. The American newspapers sometimes contained complaints from soldiers about supply difficulties. Reading carefully, we realized they were complaining about receiving only 90% of requested supplies. We had operated on 30% of minimum requirements and considered ourselves fortunate. Their definition of critical shortage was our definition of unimaginable abundance. We were not fighting the same war in any meaningful sense. January 1945 arrived with American synthetic rubber production approaching 1 million tons annually, a rate of production that exceeded total German wartime production every 4 months. German synthetic rubber production, by contrast, had collapsed under the weight of Allied bombing campaigns and critical shortages of raw materials. The massive IG Farben plant at Schkopau had been hit repeatedly by Allied bombers, with production disrupted severely despite extensive repair efforts. The Hüls facility had been destroyed almost completely in a series of devastating raids. Smaller plants had ceased production entirely for lack of the coal, petroleum, and chemical feedstocks necessary to synthesize rubber. By early 1945, German monthly production had fallen below 10,000 tons, barely 1% of American monthly output. This extraordinary disparity reflected fundamentally different approaches to warfare, industrial organization, and social mobilization. America had mobilized its entire population regardless of race, gender, or national origin in a vast cooperative effort. Women comprised 65% or more of the workforce in some rubber manufacturing plants. African Americans held supervisory positions managing integrated work teams. Recent immigrants from Europe, including refugees from Nazi persecution, operated complex machinery and contributed technical expertise. Former competitors worked together as partners in common cause. Government and industry cooperated effectively without resort to coercion or nationalization. The result was an industrial mobilization that exceeded anything achieved by authoritarian systems. Germany, by contrast, had systematically excluded vast portions of its human resources based on racial ideology that proved not just morally abhorrent, but practically disastrous. Women were actively discouraged from factory work because Nazi ideology emphasized their domestic roles. Foreign workers were treated as slaves whose welfare was irrelevant, predictably resulting in low productivity and active sabotage. Jewish scientists and engineers who might have solved critical technical problems had been murdered in death camps or driven into exile where they contributed to Allied victory. Competition between industrial firms continued even as the nation faced imminent defeat, with companies protecting proprietary information rather than collaborating for national survival. The Nazi system that proclaimed its superiority over democratic chaos had proved inferior in every measurable dimension of industrial and military performance. Colonel Wilhelm von Brauchitsch, son of the former Wehrmacht commander-in-chief and himself a senior officer captured in Italy, reflected on these realities during his internment at Camp Como, Mississippi. "We entered this war believing our authoritarian system was inherently more efficient than democracy because orders could be issued and implemented without debate or dissent," von Brauchitsch wrote in letters to his family that were intercepted and preserved in intelligence archives. "Our leadership structure was clear and unambiguous. Orders flowed down the chain of command and were executed without question. Yet the American system, with all its apparent chaos, its competing private companies, its argumentative labor unions, its endless democratic debates, produced material results we could not begin to approach. Their chaos proved more organized than our order. Their democracy proved more efficient than our dictatorship. These conclusions are inescapable for anyone who witnessed what I have witnessed here." Spring 1945 brought news that German officers found almost beyond belief. American production capacity had so thoroughly exceeded military requirements that synthetic rubber plants were already beginning conversion to peacetime production patterns. With the war against Germany clearly won and victory over Japan appearing inevitable despite continued fighting, American industrial planners were already retooling facilities to produce rubber for civilian automobiles, household appliances, and consumer goods. This represented a level of confidence in victory that reflected not just military success, but the fundamental economic strength that had made that military success possible. Major General Ernst Meisel, captured in the Ruhr Pocket during the final German collapse, wrote about this with a mixture of amazement and resignation. "They are so confident of victory that they are already planning for post-war prosperity while fighting continues in the Pacific," Meisel observed. "We threw our entire economy into total war mobilization, sacrificing all civilian production for military needs, and still lost decisively. They maintained substantial civilian production throughout the war, supplied military forces with material abundance we could not imagine, and still have surplus capacity to begin transitioning back to peacetime production before the war has even ended. The scale of their economic power makes military resistance fundamentally pointless. When Germany surrendered unconditionally on May 8, 1945, American officials visiting prisoner of war camps revealed information that stunned the German officers who heard it. The United States would not only refrain from dismantling German chemical industry as punishment for aggression, it would actually provide synthetic rubber technology to help rebuild German industrial capacity. The plants that had supplied Allied military forces with the tires that enabled victory would share their technical knowledge with the defeated enemy, helping Germany re-establish synthetic rubber production using the superior American processes. This generosity seemed incomprehensible to men raised on Nazi ideology that portrayed international relations as zero-sum competition, where one nation's gain was another's loss. The explanation offered by American officials reflected a fundamentally different worldview. Prosperous neighbours made better trading partners and more stable democracies than impoverished, resentful populations. A rebuilt Germany with functioning industry would contribute to European stability and prosperity rather than serving as a source of future conflict. The synthetic rubber technology that had helped defeat Nazi aggression would now help build democratic peace by providing employment, creating economic growth, and demonstrating the benefits of democratic capitalism over authoritarian alternatives. German chemical companies would receive assistance in establishing new synthetic rubber plants using American processes, creating the industrial base for economic recovery that would anchor German democracy. Throughout summer 1945, as German prisoners awaited repatriation to a homeland divided among occupying powers and devastated by years of war, they continued witnessing the material abundance that characterized American society. The plants that had supplied military tires during the war were now producing civilian tires for the explosion of automobile ownership that would define post-war American prosperity. German officers, many of whom would eventually play important roles in rebuilding West Germany, observed these developments and took careful mental notes about the relationship between democratic institutions, industrial capitalism, and material prosperity. Colonel Hans Röttiger, who would later become a key figure in establishing the Bundeswehr as West Germany's new democratic military, spent his months of captivity at Camp Polk, Louisiana, carefully studying American industrial and military organization. His notebooks, preserved in German military archives, reveal systematic observations about what made American mobilization successful. The essential lesson, Röttiger wrote in an entry dated July 1945, is that synthetic rubber production, like all forms of industrial mobilization, requires not just technical knowledge and industrial capacity, but social cooperation on a massive scale. Germany possessed the technical knowledge, our chemists were world-class and pioneered synthetic rubber development. We partially achieved the necessary industrial capacity, though never to the extent required. What we completely failed to achieve was the social cooperation that American democracy generated naturally. American success came from genuinely mobilizing their entire society, every race, every gender, every social class, in common cause. Our ideology systematically excluded large portions of our population, and we paid the price for that exclusion. The repatriation of German officers began in late 1945 and continued through 1947, a gradual process that returned men to a homeland that bore little resemblance to the nation they had left years earlier. They found cities reduced to rubble by Allied bombing, an economy that had virtually ceased functioning, a population traumatized by defeat and desperate for food and shelter. Germany was divided into occupation zones controlled by the Soviet Union, United States, Britain, and France, with the division that would eventually become permanent already apparent. But these returning officers carried with them memories of American material abundance and hard-won knowledge that democracy could mobilize resources more effectively than dictatorship, that cooperation could achieve what coercion could not, that inclusive societies outperformed those based on racial hierarchy. Many former Wehrmacht officers would become advocates for democratic reconstruction precisely because they had witnessed the material superiority that democracy had generated. General Günther Blumentritt became an important advisor to British occupation forces, contributing his expertise to the development of democratic institutions in the British zone. Hans Speidel, who had served as Rommel's chief of staff, would rise to become NATO's commander-in-chief of Allied ground forces Central Europe, a position of trust that would have been unthinkable without his commitment to democratic principles. The experience of captivity in America, witnessing industrial abundance and democratic social organization, had transformed men who might otherwise have remained wedded to authoritarian ideas. The statistical record tells the complete story with brutal clarity. Between 1942 and 1945, the United States produced approximately 2 million tons of synthetic rubber, with annual production reaching 920,000 tons by war's end. Germany produced roughly 350,000 tons throughout the entire war, peaking at 120,000 tons annually in 1943 and declining thereafter. By 1945, American monthly production exceeded Germany's best annual production by a substantial margin. A single American plant often matched Germany's entire national output. The disparity was so overwhelming that it rendered German military resistance futile regardless of tactical skill or operational brilliance. No amount of superior generalship could overcome a 10-to-1 disadvantage in the fundamental materials of mechanized warfare. West Germany, rebuilt with Marshall Plan assistance that included sharing American synthetic rubber technology and manufacturing expertise, would become an industrial powerhouse that exceeded Nazi Germany's wildest economic ambitions. The same chemical companies that had struggled to produce adequate rubber for Wehrmacht vehicles would produce abundant rubber for a civilian economy that generated prosperity unprecedented in German history. BASF, the successor to portions of the dismantled IG Farben empire, would become one of the world's largest chemical companies. German automobile manufacturers would produce vehicles that dominated global markets. The economic miracle of West German reconstruction demonstrated conclusively that prosperity came from production and trade, not from conquest and plunder. The transformation was complete and irrevocable. German military officers who had begun the war believing in their nation's technical superiority and their ideology's validity had witnessed the overwhelming productive capacity of American democracy. The synthetic rubber program had demonstrated beyond any possibility of doubt that modern war was won in factories and laboratories as much as on battlefields, that industrial mobilization required social cooperation that only democracy could generate, that inclusive societies outperformed exclusive ones in every measurable dimension. General Heinz Guderian, the brilliant architect of Blitzkrieg doctrine who had watched his mechanized forces gradually grind to immobility for want of rubber, wrote before his death in 1954 words that acknowledged this reality without reservation. "We conquered France in 6 weeks with armies that moved on rubber tires," Guderian observed. "We were defeated by Russia and America because we ran out of rubber while they manufactured unlimited quantities. The synthetic rubber plants of America were ultimately more decisive than any battle we fought. Superior logistics defeated superior tactics. Industrial abundance defeated military skill." Hans Speidel, in his memoir published years after the war, summarized the broader lesson that synthetic rubber production exemplified. The American synthetic rubber program proved definitively that democratic societies could outproduce dictatorships, that diverse populations could outperform racial hierarchies, that voluntary cooperation could achieve results that coercion could never match, Speidel wrote. Every German officer who witnessed American tire production, who saw the abundance of resources allocated even to prisoner of war camps, who observed the genuine enthusiasm of American workers, understood at some level that we had lost not just militarily, but philosophically. Our ideology had been tested against reality and found completely wanting. The future belonged to democracy not because of superior moral claims, though those existed, but because democracy generated superior material results. Today, synthetic rubber comprises approximately 70% of global rubber production, a direct legacy of the wartime program that demonstrated the viability of large-scale synthetic production. The German generals who witnessed American industrial might during their years of captivity learned lessons that shaped post-war Germany's commitment to democracy and peaceful prosperity. They understood that prosperity came from production, not conquest, that strength came from cooperation, not domination, that inclusive democratic societies possessed advantages that authoritarian systems could never overcome. The American synthetic rubber program had demonstrated the superiority of democratic industrial mobilization over authoritarian control, proving forever that free societies, when properly mobilized, could generate resources that dictatorships could only dream of matching.